By 2008, Caterpillar put its name on the largest hydraulic excavator the world had ever seen, the CAT 8750, an 800-ton class mining excavator with a bucket large enough to swallow a pickup truck whole. Developed from the proven Bucyrus RH400 platform, the machine promised a new era of ultra-class mining efficiency, fewer machines, fewer operators, more material moved per pass. A Caterpillar mining brochure that year called it the most productive single-dig machine ever offered to the global mining market. Trade journals echoed the awe, citing a bucket that held 61 to 76 cubic meters, dual MTU engines exceeding 4,400 horsepower, and a working envelope designed for the deepest pits on Earth. On paper, it was unbeatable. On the job site, it was terrifyingly dependent. One machine, one supplier, one failure point. The CAT 8750 could move mountains, but what happens when an entire operation is built around something that big? How does the most capable excavator ever built become a liability instead of a triumph? Long before Caterpillar ever painted an ultra-class machine yellow, the DNA of the 8750 lived in Milwaukee, where Bucyrus built steam shovels that shaped American mining and dam construction. Founded in the 1880s in Bucyrus, Ohio, before relocating to Wisconsin, the company earned its reputation not through innovation alone, but through survival. Their machines dug the Panama Canal from 1904 to 1914, setting a precedent that would define mining equipment for a century. Fewer machines, massive scale, absolute reliability. Period engineering catalogs from the 1920s emphasized simplicity and durability, virtues that carried forward into Bucyrus, later electric rope shovels, and eventually hydraulics. The company's engineering culture was built on a single obsession articulated in a 1978 Society of Mining Engineers conference paper by former Bucyrus engineer Alfred Yeager. He put it simply, if it can't survive a mine, it doesn't ship. This reputation mattered in ways that transcended marketing. Mining companies trusted Bucyrus not because machines were cheap, capital equipment never was, but because downtime was catastrophic. A stopped shovel meant idle haul trucks, idle crushers, idle mills, and idle shifts. In copper, coal, and iron ore operations stretched across continents, reliability became the only spec that truly mattered. Bucyrus understood this at a molecular level. Their steam shovels gave way to electric rope shovels, massive cable-operated machines that could load 100-ton trucks in 3 passes. But by the 1970s, the rope shovel model faced limits. They were immobile, tethered to power cables, slow to redeploy when pit layouts changed. Flexibility mattered more as mines expanded horizontally and mining plans grew more dynamic. The company that would birth the world's largest excavator was built on one obsession: uptime. That obsession would carry forward into hydraulics, even as the industry resisted the transition. By the late 1970s, mining faced a technological contradiction. Electric rope shovels dominated ultra-class loading, with bucket capacities exceeding 40 cubic meters and proven track records measured in decades, but they were immobile, power-hungry, and slow to redeploy. Hydraulic excavators offered flexibility, speed, and independence from electrical infrastructure, but early models lacked the scale and longevity mining operations required. Trade journals like Mining Engineering noted operator skepticism throughout the early 1980s. One frequently cited concern appeared in a 1981 equipment review: hydraulics are fast until they fail. The concern was not unfounded. Hydraulic systems require precision manufacturing, contamination control, and component replacement cycles unfamiliar to rope shovel operators trained on cable drums and gearboxes. European manufacturers such as O and K and Demag began pushing hydraulic mining excavators into larger classes during this period, but North American mines hesitated. Parts logistics, training infrastructure, and resale value all favored rope machines. A mine superintendent facing a board of directors did not gamble on unproven technology when proven alternatives existed. Bucyrus engineers began quietly experimenting anyway. Their question was not whether hydraulics could move faster. That was obvious. The question was whether hydraulics could survive mining duty cycles measured in decades, operating in dust, heat, cold, and continuous loading under maximum bucket weight. Internal testing focused on redundancy, serviceability, and component durability. Could hydraulic pumps survive 20,000-hour service intervals? Could cylinders withstand side loading from uneven pit floors? Could filtration systems handle the fine dust that infiltrated every seal? Hydraulics were not rejected because they did not work. They were rejected because failure was unforgivable. Bucyrus knew this. They also knew that if they could solve the durability problem, hydraulics could redefine ultra-class loading entirely. Bucyrus's acquisition of O&K Mining in 1997 changed everything. O&K, based in Dortmund, Germany, had spent decades developing the RH-120, a 120-ton class machine that proved hydraulics could survive harsh mining conditions when engineered correctly. Dealer manuals from the late 1990s highlighted the innovations that made this possible: modular hydraulic circuits that isolated failures, redundant pumps that maintained partial operation during component replacement, and simplified service access designed around real operator complaints documented in field reports. O&K had not just scaled hydraulics, they had made them maintainable under mining conditions. The cultural integration mattered as much as the technology transfer. Bucyrus brought American mining credibility and a dealer network built on rope, shovel trust. O&K brought European hydraulic precision and 2 decades of incremental refinement. Together, they had both the technology and the reputation to attempt what neither could accomplish alone: a hydraulic excavator large enough to challenge rope shovels in the ultra-class market. One Canadian mine supervisor wrote, in a 1999 Bucyrus dealer survey response preserved in company archives, "It loads like a rope shovel, but moves like an excavator." That changes planning. The comment captured the shift. Hydraulics were not just faster cycle tools anymore. They were strategic assets that allowed mines to reconfigure loading zones without electrical infrastructure, to respond to ore body changes more dynamically, to reduce dependency on fixed power grids. Trust followed performance data. Uptime percentages climbed. Maintenance intervals stabilized. Dealer confidence grew. So did ambition, because once a mine believes hydraulics can scale, the only remaining question is how far they can be pushed before something fundamental breaks. Innovation begins quietly, in proving grounds rather than press releases, in field reports rather than brochures. In the early 2000s, Bucyrus greenlit the RH-400, a machine that rewrote hydraulic limits and announced that the era of compromise was over. Introduced commercially in 2006 after years of prototype testing, the RH-400 carried an operating weight near 980 tons and bucket capacities exceeding 45 cubic meters, placing it firmly in territory previously reserved for electric rope shovels. Period brochures emphasized redundancy and durability as core design principles. Twin Cummins QSK-60 diesel engines produced over 3,360 combined horsepower. Multiple independent hydraulic circuits allowed partial operation during component failure. Serviceability was designed specifically for remote mines where factory technicians might be days away. The machine wasn't just large, it was systematically engineered to minimize the catastrophic single-point failures that had plagued earlier hydraulic attempts at this scale. Operators noticed the difference immediately. A 2007 Equipment World feature profiling early Australian deployments quoted a Pilbara mine operator who said, "It doesn't feel big, it feels controlled." The comment wasn't marketing hyperbole. Control precision in ultra-class excavators had always been the compromise for power. Rope shovels were powerful but coarse. The RH-400 delivered both. The hydraulic system responded to operator inputs with a smoothness unfamiliar in machines of this mass. Bucket breakout force exceeded 1,600 kilonewtons. Slew speed remained consistent under load. Digging depth reached 10 meters. And critically, the machine delivered these specifications while remaining mobile, independent of electrical infrastructure, and capable of relocation within a pit in hours rather than days. The RH-400 wasn't just large, it was predictable. That predictability made mining planners bold, because predictable machines allowed tighter cycle time calculations, more aggressive fleet sizing, and operational models built around assumptions that had previously been too risky to implement. Once mines trust predictability, they redesign everything around it. Mining planners across Australia, Canada, and Chile began consolidating fleets around ultra-class hydraulic excavators between 2006 and 2008. The operational logic was seductive and backed by fleet management software that made the math undeniable. Instead of deploying multiple mid-sized loaders, feeding a haul truck fleet in parallel, a single RH400 could anchor an entire loading face, filling 320-ton and 400-ton haul trucks in 3 to 4 passes. Efficiency gains appeared across multiple cost centers. Fewer operators meant reduced labor overhead, training costs, and shift complexity. Lower fuel burn per ton moved improved operational cost metrics that mining executives presented to boards and investors. Faster cycle times increased hourly production tonnage, allowing mines to meet output targets with fewer total machine hours. Simplified dispatch logic reduced coordination overhead and allowed smaller operations teams to manage larger pits. But buried in internal Bucyrus planning memos and service bulletins from 2008 was a warning that would age poorly. Ultra-class hydraulic excavators represented single-point dependencies that required pre-positioned spares and factory response coordination to avoid catastrophic operational disruptions. The concern was documented but not emphasized. A footnote in brochures focused on capability rather than vulnerability. The problem was structural. When a mine deployed 3 mid-sized excavators, one could fail without stopping production entirely. Redundancy was distributed across the fleet, but when a mine redesigned operations around one ultra-class machine, that machine became the linchpin. A hydraulic pump failure, a structural crack, a contaminated oil system, any of these could halt loading operations entirely while parts were sourced, technicians were flown in, and repairs were executed. Mining planners understood this theoretically, but the efficiency gains were too compelling to resist. Quarterly cost reports rewarded consolidation. Fleet management software showed payback periods measured in months. The risks were documented, acknowledged, and accepted. Efficiency increases concentration. Concentration magnifies failure. In July 2010, Caterpillar acquired Bucyrus International for $8.6 billion, one of the largest acquisitions in Caterpillar's history, and a clear signal of strategic intent in the global mining equipment market. For Caterpillar, the logic was straightforward and compelling. Bucyrus filled a critical gap in Cat's mining portfolio, particularly in ultra-class excavators and rope shovels, where Cat had limited presence. The acquisition allowed immediate ownership of the ultra-class hydraulic excavator category without the decade-long development timeline required to engineer competitive machines from scratch. And critically, it promised integration of Bucyrus's mining expertise into Caterpillar's global dealer network, the largest and most geographically distributed heavy equipment service infrastructure in the industry. Internal Caterpillar presentations from late 2010 emphasized unmatched global support for ultra-class machines as a core value proposition. The pitch to mining companies was clear. Bucyrus had built the machines, but Caterpillar could service them anywhere, with parts availability, technician training, and response times that independent manufacturers could not match. The RH400 platform, already proven, already deployed, already trusted, would become the foundation of something new. Caterpillar's brand equity, built over decades in construction and general excavation, would now extend into the deepest mines on Earth. The yellow paint would carry connotations of reliability, parts availability, and dealer support that even Bucyrus's excellent reputation could not fully replicate. For mining companies already operating RH400 units, the acquisition offered reassurance. Caterpillar's financial stability and global scale suggested long-term parts support and service continuity, concerns that always lingered with smaller specialized manufacturers. For mines considering ultra-class hydraulic excavators, the Caterpillar name reduced perceived risk. But the acquisition also introduced pressure. Dealer networks needed training, parts inventories needed expansion, service protocols needed documentation, and critically, the machine that would emerge from this transition would carry not just technical specifications but the weight of 2 reputations. When a giant acquires innovation, scale becomes both the promise and the pressure. By 2011, the machine emerged from Caterpillar's integration process as the CAT 8750, a rebranded and slightly refined evolution of the proven RH400 platform. The yellow paint was unmistakable, the three-stripe Caterpillar logo prominent on the counterweight housing. But beneath the cosmetic changes, the engineering remained fundamentally rooted in Bucyrus and O and K hydraulic expertise developed over 2 decades. The specifications remained monstrous and unmatched in the hydraulic excavator category. Operating weight ranged between 800 and 820 metric tons, depending on configuration and attachment selection. Power came from dual MTU 20V 4000 diesel engines chosen for their reliability in remote mining environments and their combined output exceeding 4,400 horsepower. Bucket capacity reached up to 76 cubic meters in overburden configurations, though most coal and copper applications specified buckets between 61 and 65 cubic meters to optimize cycle times for 400-ton haul truck fleets. Caterpillar literature framed the 8750 not merely as a machine but as a system centerpiece, the anchor around which modern mining operations could be designed. Marketing materials emphasized integration with CAT's haul truck fleet, compatibility with MineStar fleet management systems, and optimization algorithms that calculated optimal bucket sizes, swing angles, and spotting positions for maximum hourly tonnage. Dealers echoed the confidence. A North American Caterpillar dealer newsletter from late 2011 described the 8750 as the anchor of the modern mine, language that revealed both the promise and the emerging vulnerability. Anchors provide stability. Anchors hold formations together against current and tide. But anchors are also immobile, dependent, and singular. The machine represented the convergence of 3 legacies: Bucyrus mining credibility, O and K hydraulic precision, and Caterpillar's global service scale. On paper, this convergence should have been unbeatable. The best engineering, the best reputation, the best support infrastructure, all unified under a single brand that mining companies already trusted for dozers, trucks, and graders. But anchors do not move, and when the current changes, anchors either hold everything in place or drag everything down. Early deployments of the K8750 between 2011 and 2013 performed precisely as advertised, validating both the engineering and the integration effort. Cycle times dropped measurably compared to previous generation loaders. Fuel burn per ton improved due to optimized hydraulic efficiency and better matching between bucket capacity and haul truck payload. Operators consistently praised control smoothness, visibility from the elevated cab, and the responsiveness of hydraulic circuits even under maximum load conditions. Mining operations in Chile's Copper Belt, Australia's Pilbara iron ore region, and Alberta's oil sands deployed 8,750 units as centerpiece loaders, often redesigning pit layouts and haul road networks specifically around the machine's working envelope and reach capabilities. Quarterly production reports showed tonnage increases and cost per ton reductions that justified the capital investment, typically between $8 million and $10 million per unit depending on configuration and delivery location. But Caterpillar's dealer network struggled with the scale and specialization required for ultra-class support, unlike wheel loaders or mid-sized excavators that could be serviced with parts stocked at regional warehouses. The KT8750 required components that were not economical to distribute broadly. Hydraulic cylinders weighed tons and required specialized transport. Main pumps needed factory precision during replacement. Structural repairs demanded welding expertise specific to high-strength steel frames operating under extreme cyclic loads. A 2013 internal Caterpillar service update distributed to dealer networks supporting ultra-class mining equipment acknowledged response times for critical component failures that were measured in weeks rather than days. Shipping hydraulic components from manufacturing facilities in Germany or the United States to remote mine sites in South America or Australia involved customs clearance, freight logistics, and lead times that could not be compressed without prepositioning expensive inventory at every potential deployment location. Mining operations do not pause production for weeks while waiting for parts. When an 8750 stopped, Mines either operated at drastically reduced capacity with backup loaders or faced complete loading stoppages that cascaded through entire operations. The breakthrough worked. The machine delivered on every technical promise, but the infrastructure required to support machines at this scale lagged behind the ambition that had created them. At peak operational performance between 2012 and 2014, the CAT 8750 was unmatched in capability, efficiency, and sheer physical presence. Bucket passes loaded 400-ton Caterpillar 797 haul trucks in under 4 cycles, a loading rhythm that optimized truck utilization and minimized queue times at the face. The boom shadow stretched across open pits like the profile of an industrial cathedral, visible from satellite imagery and unmistakable in scale. Operators who worked daily with the machine described it in consistent terms across different mine sites: smooth, deliberate, unstoppable. The hydraulic controls responded with precision unusual for machines of this mass. Bucket breakout force allowed single pass loading of blasted overburden that would have required multiple passes from smaller excavators. The elevated cab provided visibility across the entire loading area, allowing operators to coordinate truck spotting, monitor face conditions, and anticipate equipment movement with situational awareness impossible in smaller machines. But the machine's scale systematically erased redundancy from mining operations. When the 8750 operated, it became the production bottleneck by design. Every haul truck in the fleet depended on its cycle time. Every production target assumed its availability. Every shift plan centered around its operational hours. This was not a flaw. It was the intended efficiency model that made ultra-class excavators economically rational. The vulnerability emerged when the machine stopped. Hydraulic pump failures, structural cracks in boom sections, contamination in oil systems, electrical faults in control circuits. Any of these could halt loading operations entirely. Backup excavators, when available, lacked the bucket capacity and reach to maintain production rates. Mines designed around 8750 cycle times could not simply substitute smaller equipment without accepting dramatic tonnage reductions. The efficiency that justified the capital investment also eliminated operational flexibility. Maximum efficiency leaves no room for backup plans, no margin for component failures, no redundancy when predictability breaks down. This was not unique to the 8750. It was the fundamental trade-off of ultra-class mining equipment, a trade-off that became acute as mines increasingly consolidated fleets around single large machines rather than distributed capacity across multiple smaller units. Between 2012 and 2015, Komatsu, Liebherr, and Hitachi responded to Caterpillar's ultra-class dominance, not by building larger machines, but by emphasizing fleet resilience through distributed capacity. Their pitch to mining companies shifted away from peak efficiency metrics and toward operational continuity and risk mitigation. Komatsu's PC8000 hydraulic excavator, operating in the 710-ton class with bucket capacities around 42 cubic meters, was marketed explicitly as part of a multi-machine loading strategy. Instead of anchoring an operation around one massive excavator, mines could deploy 2 or 3 PC8000 units across different loading phases, maintaining production even when one unit required maintenance or suffered component failure. Liebherr's R996B followed similar logic, prioritizing serviceability and parts commonality with smaller excavator models already in widespread use. Hitachi emphasized modular component design and shorter lead times for critical parts, addressing the vulnerability Caterpillar's dealer network had struggled to solve. Their marketing materials included case studies showing total operational uptime percentages across fleets rather than individual machine capabilities, a subtle but deliberate reframing of the value proposition. Mining chief financial officers listened carefully to these pitches. Financial models that had initially favored ultra-class consolidation began incorporating downtime risk more explicitly. When a single 8750 stoppage could idle an entire haul truck fleet and miss daily production targets, the cost of redundancy through multiple smaller machines became easier to justify even if fuel efficiency and operator count favored the larger unit. The competitive response was not about building a bigger excavator. Caterpillar had already proven that market. The response was about demonstrating that survivability and operational continuity mattered more than peak capability, particularly in commodity markets where production consistency determined profitability more than marginal efficiency gains. The market was no longer rewarding dominance. It was rewarding survivability, flexibility, and the ability to maintain production targets even when individual machines failed. The 8750 remained the most capable hydraulic excavator in the world, but capability alone no longer guaranteed fleet selection when operational risk entered the calculation. Between 2014 and 2016, the ultra-class hydraulic excavator market that Bucyrus had pioneered and Caterpillar had branded underwent a quiet but fundamental transformation. What had once been miraculous, a hydraulic excavator matching rope shovel scale, became just another equipment option in mine planning software. The category that did not exist in 2000 was now populated by multiple manufacturers offering comparable capabilities with different risk profiles and support models. The 8750's uniqueness faded, not because the machine became less capable, but because alternatives proliferated. Mining companies evaluating fleet investments compared Caterpillar's ultra-class offering against Komatsu's distributed capacity model, Liebherr's serviceability emphasis, and Hitachi's parts availability claims. The conversation shifted from can hydraulics work at this scale to which hydraulic strategy minimizes operational risk. Caterpillar's ultra-class sales growth slowed measurably after 2014. New mine developments increasingly specified multiple mid-sized excavators rather than single ultra-class units. Existing 8750 operators expressed satisfaction with machine performance but hesitation about fleet expansion when component lead times remained measured in weeks and parts costs required dedicated budget line items. The machine had not failed. Every 8750 in operation continued delivering the tonnage, efficiency, and capability that justified its initial purchase. Operators still described it as smooth and powerful. Maintenance records showed durability matching or exceeding initial projections. The engineering remained sound, but the strategy that made the machine revolutionary, concentrating capacity in a single massive unit, had been commoditized. Once competitors proved that ultra-class hydraulic excavators were feasible, the advantages of being first eroded. Caterpillar's dealer network advantages mattered less when competitors offered faster parts response. The yellow paint carried less weight when mining chief financial officers prioritized operational continuity over brand loyalty. The 8750 had proved that ultra-class hydraulics could work. In doing so, it created a category that other manufacturers could enter without bearing the development risk, without investing in unproven technology, and without convincing skeptical minds that hydraulics could scale. Being first does not protect you once the category exists. It makes you the benchmark competitors refine against. The commodity price collapse between 2015 and 2017 devastated global mining capital expenditure budgets with a speed and severity that caught even experienced mining executives unprepared. Iron ore prices fell from over $120 per ton in early 2014 to below $40 by late 2015. Copper, coal, and nickel followed similar trajectories. Mining companies shifted immediately from expansion mode to survival mode, slashing exploration budgets, deferring maintenance, and halting all non-essential equipment purchases. Ultra-class excavators were hardest to justify under these conditions. When mines cut capital budgets by 60% or more, equipment purchases prioritized immediate operational needs and versatile machines that could adapt to changing pit layouts and reduce production targets. An $8 million excavator that anchored an entire operation made sense during expansion cycles with strong commodity prices. During contraction, that same capital commitment represented concentration risk that CFOs and boards refused to accept. Financing for ultra-class equipment evaporated as banks tightened lending criteria and required higher equity contributions for mining projects. Equipment leasing companies reduced exposure to specialized machinery with limited resale markets. The secondary market for used 8750 units effectively disappeared. Who would purchase an 800-ton excavator when new mine developments had stopped entirely? Some 8750 units were parked in equipment yards, maintained but idle, waiting for commodity cycles to turn. Others continued running in operations too dependent on their capacity to be shut down, but they operated with deferred maintenance schedules and extended component replacement intervals that would have been unacceptable during profitable years. Mines that had designed entire loading operations around ultra-class excavators could not easily substitute smaller equipment without accepting production cuts that made operations uneconomical. The recession exposed what competition had already suggested. Ultra-class excavators delivered maximum efficiency under optimal conditions but offered minimum flexibility when conditions deteriorated. When markets contracted, the biggest machines were the first to be silenced, not because they failed technically, but because they represented capital concentration that commodity cycles punished ruthlessly. The 8750 remained capable. The market had simply moved to a place where capability without flexibility became a liability. Today, CAT 8750 units continue operating in active mines across Australia, Chile, and Canada, still capable of the tonnage and efficiency that justified their purchase a decade ago. Others sit in equipment yards and archives, retired not from mechanical failure but from strategic obsolescence. Their massive frames remain intact, hydraulic systems still functional, yellow paint faded but recognizable. Parts supply continues through Caterpillar's global network, though lead times remain long and costs remain high for components serving a limited installed base. The machines influenced every modern ultra-class hydraulic excavator that followed them. Komatsu's PC8000, Liebherr's R8800, Hitachi's X8000. All reflect lessons learned from the RH400 and A750 platforms about hydraulic circuit redundancy, boom structure optimization, and control system precision at extreme scale. The engineering that Bucyrus pioneered in Milwaukee and Germany, refined through O&K expertise, and branded by Caterpillar became the foundation of an entire category. But the vision that drove the machine's creation, the idea that one massive excavator could anchor an entire mining operation more efficiently than distributed capacity, faded as mining companies learned painful lessons about concentration risk during commodity downturns. Modern mine planning increasingly favors operational resilience over peak efficiency, distributing capacity across multiple units that can flex with changing conditions and survive individual component failures without stopping production entirely. The technical achievement remains undeniable. An 800-ton hydraulic excavator that operates reliably in the harshest environments on Earth represents engineering at its finest. The operators who ran them, the engineers who designed them, and the companies that built them created something genuinely remarkable. But equipment that makes financial sense during commodity booms becomes vulnerability during busts. Machines that optimize efficiency during expansion become anchors during contraction. The 8750 was not wrong. It was precisely right for conditions that proved unsustainable. The final image mirrors the first. A massive excavator still intact, still powerful, no longer central to the operations around it. The machine worked perfectly. The market moved on anyway. Innovation built the capability. Scale decided who survived long enough to own it.